Today's webinar is about TPM, 30 years on. Presenting the session today is Ross Kennedy. Ross is the President and Founder of CTPM, a team of business improvement coaches. He is recognized as Australasia's leading authority on total productive maintenance and CTPM's Australasian TPM lean approach to operational excellence. So let's get started with today's session, and I'll now pass you over to Ross.
Good morning, everyone, and thank you for joining our webinar today on TPM 30 years on. It was this year, 30 years ago, 1989 to be precise, that the first authoritative book on TPM was published in English, which I'll show you in a minute. So I thought it'd be a good opportunity just to reflect back on TPM and talk a little bit about, probably just refresh our memory. What is TPM? Why do it? What are the benefits that we've seen over the last 30 years? Should we be calling it total productive maintenance or total productive manufacturing or some other name? What model works best? There are various models. Originally there was a 5-pillar, then there was an 8-pillar, then there was the 10 activities, and we've got 10 integrated ingredients now. So what is the best model to use? Getting the focus right. Should it be we're out there to fix the equipment up, or are we out there to develop our people who can then fix the equipment up? And it's quite a subtle difference between the two. And finally, impact of not getting the sequence right. And we've developed a checklist which we'll share with you to explain why sequencing is so important. But just to start with, TPM, the first book by Mr. Seki Nakajima, who was the then president of the Japan Institute of Plant Maintenance. TPM, as we know, was developed or identified by the Japan Institute of Plant Maintenance back in 1970. They wrote their first book on it, which they called TPM Tenkai, which was released in 1982, and then in 1989 it was published in America by Productivity Press. I think Norm Bodek was the gentleman who brought it over from Japan and said, this is important, we should all learn about it. So, yep, 30 years on. So, what is TPM, or Total Productive Maintenance? TPM is an equipment management improvement strategy developed by Toyota in 1970 to support their Toyota production system, or lean production. And it was based on the learning from Dr. Edward Deming. As we know, Dr. Deming was over there in, after the war, after the Second World War, to help the Japanese learn about improved manufacturing techniques, and quality being the key one. And he introduced some key points about how to get improved quality. And those 3 points were focus on the process, not just the activity, apply prevention at source for the process, and recognize the tyranny of time when addressing problems. The tyranny of time is simply the time between when a problem occurs and when you actually find out about it. The longer that time gap, the harder it is to get to the root cause. And so he was saying it's all about prevention at source, finding your problems at the earliest possible time in your processes to ensure to get higher quality at lower cost. So this slide's been around for a long time, which is just simply saying if you go and find your problems at the very start of your process, for example, if your raw material is not correct and you pick up on it and reject it, it's the cost of the raw material. If you process your raw material and you end up at the end of the process looking at it and saying, hey, this is out of spec, and reject it, you've spent all that money processing the raw material, and it becomes a lot more expensive quality issue. If you give it to the customer, obviously, not only do you have to replace it, but you have the collateral damage of customers being upset and sales and marketing people getting involved, etc., etc. So the key message was simply find problems at the earliest possible time. Now, as Toyota were trying to apply this thinking in their workplace with their equipment, they found that equipment reliability became a critical issue, especially as they were trying to pull out inventory between equipment and link their equipment together. So they had minimum time between when one item or part was made and moved on to the next process. So if there was a problem, you could pick up on it and go back and address it rapidly, addressing the tyranny of time. But what that meant was if the equipment broke down, you had a whole chain of equipment that then went out of, or process line went out of action. So they realized that if they could apply prevention at source to equipment, they could address this problem. And the concept was all based around, let's find the little problems at the earliest possible time and fix them rather than wait until they become big problems. So, for example, you may get a damaged grease line on a machine that feeds grease into a bearing assembly. If you don't pick up on the fact that the grease line is now damaged and not feeding grease into the bearing properly, after a period of time, and it could be quite some considerable time, that the bearing will actually fail. And if the bearing fails, you're up for obviously extended downtime and the cost of bearing assembly, etc., for replacement. So it becomes quite expensive, as opposed to just going and picking up that the grease line's being damaged and fixing it then and there. It can be a very small job, very cheap with minimal downtime. So it's a simple concept that makes sense. Find problems at the earliest possible time. However, Toyota was soon faced with a number of challenges as they tried to apply prevention at source to the equipment. First one being, well, we'll get the maintenance people to go and find all the little problems instead of waiting for the bearings to fail. Well, there just wasn't enough maintenance people to do that. So the only answer was, well, we have to get the operators involved and get the operators to find the little problems on their equipment and find the equipment defects and then tell the maintenance people, and the maintenance people come and fix them. So they said that's about the only way we can get this to work. But then they had some other challenges. And these are probably the 6 key ones that they were faced. How do we create time to develop all our people, especially the operators, because they're busy operating the equipment? So how do we go and give them time to stop operating the equipment and learn about and go finding defects? How do we train all the operators to know what to look for to find equipment defects and problems? Because it's all very well saying to an operator, go find a defect, but our experience has been, in most cases, they don't know what they're looking for. Third, how do we change the existing equipment so it's easy for operators to find the equipment defects or problems? So we don't want them spending a lot of time doing it, but we want to be very, very effective with their time. So therefore, we need to change the equipment, like get rid of metal covers and put perspex on it, put lighting behind it, put visual controls in, etc. So some changes that need to bring the air service units up to their eye level rather than having them down at ground level. A lot of changes need to be made, but we need to get that done somehow. Ensure any new equipment that comes into the place is designed such as easy for operators to find the equipment defects or problems. So how do we introduce what they call new equipment management to do that? And then create a maintenance support capability that can respond to small equipment defects or problems identified by the operators rather than rely solely on traditional work order priorities. Traditional work order priorities are simply saying the most important thing gets the highest priority. So if it's a critical safety job, that gets #1 priority. If it's a breakdown, well, obviously it gets the priority. If it's affecting performance of the line, it gets a priority. By the time you get to a defect, a damaged grease line, well, it's not causing a breakdown, it's not a critical safety issue, it's not causing performance of the line. So, well, when we get time, we'll get to it. And then by the time you do get to them, they become a lot more serious problems. And also the people who found the defect get disillusioned because no one's doing anything about it. And finally, stabilize the production plan to ensure regular clean for inspections by operators supported by maintenance. Develop the prevention skills of our operators and maintainers. you need to have regular clean for inspections. And maintenance are very busy people, and if you start having them all over the place, all over the different times, maintenance may not be available. So you've got to say, right, Tuesday morning, 11 o'clock, we'll have a clean for inspection. So we need a stable production plan, so we know at 11 o'clock on Tuesday mornings we're going to shut the machine down. We'll probably do a changeover at the same time. We'll do our clean for inspection, and off we go again. And everyone knows it happens, and everyone can be prepared. But you can only do that if you've got a stable production plan. So how did they address these things? What were the possible solutions? So just going through those 6 key challenges, create time to develop all our people, especially operators, was to improve OEE so as to make more good output in less time. So by using a cross-functional team that doesn't impact on production, you can go and look at, analyze your losses. If you can improve OEE by 10%, for example, it means you're going to be making either 10% more output in the same time or making the same output in 10% less time. So you can then say, okay, that 10% we've got, maybe we can invest 4 or 5 into developing our operators through regular clean for inspections. To train our operators, we obviously need to get regular clean for inspections going. Change equipment, well, we need to address maintenance time lost so they can improve equipment, so they've got the time to do it. Maintenance is normally very busy people, and most sites we find they are stretched to the limit. But when we go and study it and analyse it with the maintenance people and start getting them to identify where they get their time lost, what we typically find is that a maintenance group will be losing something like 30 to 35% of their time each week because, for example, they get called to a job and the operator is just saying the thing's stuffed, come at maintenance, and maintenance come along and they say, well, hang on, this is an electrical problem, not a mechanical problem. You should have called the electrician. Or it might be, had I known this was the issue, I could have bought a special tool. I have to go back and get my tools. So they waste the time. Often they can't find equipment because it's not, someone else has been using it. The spare part's not readily available. The technical information is not readily available. The system takes too long to search for information. There's a myriad of things we've identified that really stuff up the maintenance people. And all they want to do is get out and do a good job. So if you go and address that one, we typically free up, when you focus on it, you can probably get that time lost down to 10%. There's 25% more maintenance resource, and they've now got the time to go and start working and supporting TPM activities. If you don't do that first, you're just going to frustrate them. New equipment coming in. Well, there's this activity called new equipment management, which starts addressing when we typically engineers go and get new equipment, their main focus is the functionality of the equipment. What does it need to do? Not how to make it easy to operate, how to make it easy to maintain, how to make it easy to train people on, how to standardize so it's easy for people to know what they're playing with, make it easy to find defects, etc. And you bring that into that equation and you have a big impact on your TPM activities. The next one, create a maintenance support capability that can respond to small equipment defects or problems. You need to introduce an equipment defect management process or system separate from the work order process. So you still keep your work order process, but you also have in parallel a defect management process so that you know the defects will get addressed at a agreed priority. So it might be 2 hours a week, we'll work on defects, right? And they will get done irrespective of the priority of other work. And that way you can actually manage your defects and make sure they are monitored and addressed to keep the operators motivated to keep finding them. And finally, the last one was just stabilize the production plan. Now, this is using what they call flow logic and Glenday sieve to create fixed time, fixed sequence production schedules for at least 50% of the output. So you take your dominant product, which typically 6% of your SKUs will probably make up 50% of your volume. If you can make that on the 2 days a week and have it fixed sequence, fixed time, you always know when you're going to do your clean for inspections. And that's, you know, another topic, but important part of the whole thing. So hence TPM was developed based on a number of integrated activities, recognizing it can be difficult to implement correctly if not done in a holistic way and in a specific sequence. Right? And the key learning is cherry picking doesn't get results. We've seen a lot of people go and say, oh, TPM, that's all about getting the operators to check the equipment. So we'll give them checklists to go and do it. Or we'll go out and get the operators and we'll do a clean for inspection, and we'll get the operators involved in the clean for inspection. It might work for 3 months at the most, and then it'll just all fall away. Right? You've got to do this in a very integrated, holistic way for it to work. Now, why do it? What's the benefit? Well, we introduced a concept of the hidden cost of poor equipment effectiveness, and we use the iceberg model, and it's designed so that the top of the iceberg is your maintenance spend, the visual stuff. You see it in the budget, it's reported on monthly, this is what we spend for maintenance. What is not reported monthly in a concise way, it's integrated, it's hidden in amongst the accounts, but it's all the inefficiencies that occur and cost you because the equipment does not run perfectly. And there's a list of them there. And what we've found from our research, and we've got papers on this if anyone's interested, there is a correlation between the OEE and the bottom of the iceberg, and it works on the basis that the lower the OEE, the bigger the bottom of the iceberg is. And from the table you can see, if for example your OEE for your production line should be say 85 and it is only running at 65, the bottom of the iceberg is probably going to be 4 times the size of your maintenance spend. And what we find is that that's not a bad estimate, keeping in mind the bottom of the iceberg covers the whole supply chain, not just your little factory, because it impacts on sales and marketing, impacts on warehouse and storage of transporting of goods and whatever if the equipment is unreliable and not making it when it should. So if we look at the concept of TPM is to, by improving OEE through various activities, is to shrink the bottom of the iceberg. And by shrinking the bottom of the iceberg is where you get significant savings. At the same time, you're also reducing your maintenance spend because you're fixing up bent grease lines rather than failed bearings. So the benefits can be quite significant. And if we think about the key success factors for operations and the key measures we look at, where you have your cause measures of safety, quality, customer satisfaction, plant and equipment, people, inventory, and they all lead into the effect, which is the costs, which is in this case maintenance cost, total operational cost. They are some of the figures that we have seen being achieved by clients who have gone down this pathway, recognizing it does take about 5 years to go down the TPM path at a site, at least, but certainly we have seen, and we've got many case studies to prove those figures to be very valid. So it is worth doing, and there's also the intangible benefits that you get from applying TPM in the workplace, where operators become more equipment competent and care for the equipment. You get a more engaged and self-motivated workforce. Everyone finds problems at the earliest possible time, not only equipment problems, but quality problems and safety problems. And getting to zero breakdown, zero quality problems, zero accidents becomes quite feasible, and it's been achieved by many of our clients. So, and the bottom one's probably the real one, operational risks minimized without high compliance costs. Sugar Australia at Glebe is a great example where they almost blew the place up before they started the TPM. This is many years ago, where they had a dust explosion because of sugar. It gets dust, and they had an elevator play up and caused sparks and had a big bang. Luckily it was contained, but it scared the hell out of everyone, as you can imagine. So they said, right, we need to stop that. So they introduced TPM, and 5 years down the track, they had achieved OEEs instead of 35, 40, they'd got them up to about 80 consistently, and they had minimized all the risk because they'd taken out all the hazards and everyone was taking care of the equipment. So it has a big impact there. Okay, so what's in the name? I think one of the things that's really impeded TPM is the name Total Productive Maintenance. Because the Japanese called it that because it made sense to them. It was total productive maintenance. The thing we need to recognize is in Japan, the word maintenance has a different meaning to the word maintenance in the Western society. In Japan, the word maintenance means caring for an asset. So for example, in Japan, washing the car would be doing maintenance on it. Whereas in Western society, we tend to use the word maintenance for repairing an asset. So if we're doing maintenance on the car, we'd be out there with the toolbox doing some maintenance work, changing the brake pads or whatever on the car. So from a Japanese perspective, total productive maintenance made a lot of sense. From the Western perspective, people looked at it and said, oh, it's all about the maintenance people, getting operators to do maintenance work, so we don't need as many operators. Let's transfer the tasks from maintenance over to operators and we save money. And it's just all nonsense. And there's a lot of misinterpretations. I know one of the first companies to go down the TPM path and win the only company in Australia to get the TPM Excellence Award from the Japanese was Nissan Casting Plant, and we're helping them in the early days, and they decided to stop all this confusion. They just call it total productive manufacturing, not total productive maintenance. Other people call it in the mining sector total productive mining, other people call it total process management, some people call it total plant management. Some companies don't even refer to the three-letter acronym of TPM, but just adopt it as a critical part of achieving operational excellence through their banner of ongoing improvement activities. And their banner might be, we have the Toyota Way, you might have the Simplot Way, there might be Goodman Fielder's Continuous Improvement Journey, whatever banner you wish to give it. Okay, point 4, what model works best? Well, there's been development of a number of models over the years. Originally, in the first book that we spoke about by Mr. Nakajima, published in 1982, written in Japanese in 1982, published in English in 1989, had 5 pillars, or they called them pillars, and it involved one, first of all, improving OEE to free up time, to then get operators involved in they called autonomous maintenance or self-governing care by operators. Their planned maintenance was all about improving the maintenance capabilities, freeing up their time so they can go and support the operators. Then obviously there's a training element to develop the skills of everyone, and finally early equipment management, which was bringing in any new equipment, had to be TPM friendly. Then later on, Dr. Suzuki wrote his book, which again published in Japan in 89 in Japanese and then English in 92, and he added an extra one on, which was about production planning. So they realized if they didn't have a stable production plan, the whole thing wouldn't work. And then, especially in Toyota, that wasn't an issue, but since they got out of Toyota, they had to really introduce that extra pillar. Then finally they came out with the next book in 92, which was published in English in 94. And you'll notice we're getting a bit quicker at publishing the books from the Japanese, because I think there's more recognition of the importance of all this. And they added, you can take TPM into not only production planning, but other support areas. Quality maintenance is really about quality care and getting perfect quality, because you can't get perfect quality unless the equipment is working perfectly. And finally, obviously, safety and environmental management. So there's been a lot of models of pillars of parthenons of the TPM process. At CTPM, we're given the charter to go out and Australasianize TPM, because all the Japanese literature is very much for the Japanese culture, and that is quite different to the Australian culture. So we went and modified the 3rd generation and came up with 10 activities, and we added lean to it and put the supply chain in, which is value stream management. Now, as a consequence of that, we came up with our hamburger, which looks at the production support, and the value stream. So from a TPM perspective, your production and production support activities. So production activities is all about freeing up time, with improving OEE using cross-functional teams and getting the production area-based teams into sorting out the work area, and then getting into operator equipment management supported by maintenance and bringing in new equipment and support department about production planning, etc. So all that was the model that we used, and we used a hamburger simply to say it's all integrated. The reason you have a hamburger is when you squeeze it, everything, all the juices come together and you get the integration of flavors. TPM is very similar to that. You've got to bring all the different activities in together in concert to get the result working for you. Now, the other, later on, and just in probably more recent times, we've introduced a new model about the bigger picture, the whole thing of achieving operational excellence, where we have proactive improvement at the top, which is all about going from where your average performance is up to world class. Now, that's where TPM fits in. So TPM is all up here. However, what we've found is if we don't do the reactive and we don't have the stable production plan, you can go and do your TPM activities, but everyone gets distracted by this not being good and you don't get very far and you stall. So we've come up with 10 integrated ingredients of Australasian TPM. So it's just looking at the TPM part of it, not the lean part. Saying how do we make sure our TPM journey is going to be effective. So we have the preparation to free up the production time. So obviously we need our daily effective daily management, we need a stable production plan, and we need to do cross-functional activity to improve OEE. Then we need to get our maintenance people's time sorted out. So we've got our maintenance time lost and then getting into good maintenance practices. Then we need to get our production people capable. So we need to make sure the operators are operating the equipment to the agreed standard and there's no variation between shifts. So that's where we need to get proper base skills established. And then we need to get the discipline within the production to sort out their work area and improve their productivity before we let them loose on the equipment. If we hang brooms in the wrong spot, it doesn't really matter. But if we stuff up a sensor on a machine doing a clean for inspection, it can have dire consequences. So we've got to get the discipline right through our work area management before we go near the equipment. Now, each area can be done, and these areas here, the capability, can all be done in parallel. But you certainly want to get all these things sorted out before you start diving into, and there's a set sequence for the operator equipment management. So that's been our learning of the TPM journey. The other key learning is that we need to address the losses for both ends of the Pareto. Recognize that TPM has two broad parts to it. One is about being the detective, what we call deductive improvement, which is using cross-functional teams, structured problem solving, and going out and looking at what the big losses are. And that's the thing that most companies do. What they often don't realize, it's all about developing the people. And you do that through your what we call inductive improvement, which is inducing an environment so we don't have a problem. So we start going and fixing up all the little defects, making sure there's no contamination on the equipment, etc. And this addresses all the tiny little losses. And we use a check, act, plan, do process to do that, which is quite different from the plan, do, check, act over here. And this is all about addressing the little losses. And what you've got to do is you first start here, but you've got to get both these working in concert. Otherwise, TPM will not get the maximum results and will not sustain. So, some quick observations about introducing regular clean for inspections. Many operators don't know how to clean equipment effectively to find equipment defects. So I've been many sites, many clean for inspections. How often operators rush in and start cleaning the equipment without thinking that why shouldn't they start at the top? Because when they clean the top, it's going to fall to the bottom. Sounds pretty basic, but sometimes they just don't really click to it until you go and ask the questions and get them engaged. The other one is most operators don't understand what an equipment defect really is. And again, I've had operators go through and clean equipment, and I'll come past and I'll pick up 4, 5, 6, 7 defects that they just haven't seen, haven't picked up on. Right? So the learning is, first of all, make sure you're able to very quickly isolate equipment quickly and safely before you start cleaning for inspection. Start cleaning at the top and work down. Work in pairs to maximize learnings. And when we're applying prevention at source of equipment, operators need to be able to find equipment defects as a habit. And what we've learned, that means taking the idea, that the thought of finding defects from being in the conscious mind into the subconscious mind. And subconscious is where we're doing things without really thinking about it. We just identify them. It's like learning to drive your car. When you first learn to drive your car, you're very much focused on where your feet go with all the pedals and how do you get the foot on the clutch when you need to slow down and whatever. And you're thinking about it, and it's very slow and it's very clunky. When you get used to having a lot of lessons and getting used to the car, now when you drive a car, you don't even think about when you have to stop suddenly. You know where your feet go, you know where to put the foot in the clutch if appropriate or whatever. It's all in the subconscious. And according to industrial psychologists, this can only be achieved if you repeat the activity at least 21 times with at least 7 sleeps in between. So if you're going to try to teach operators about finding equipment defects and get it into, so they're always looking for it subconsciously, while they're operating the equipment, they're subconsciously looking to see if there's any defects evolving. Hence, it will take some 6 months of regular weekly clean for inspections with good training, coaching for an operator to become competent in finding equipment defects. It is not let's do 1 or 2 clean for inspections, or let's do them on day shift and don't worry about afternoon shift. That won't get it there. So 21 times, if you do it weekly, that's 21 weeks, so 6 months to start getting results. And that's what we've seen. It does take time to do it properly. It is a transformation, TPM transformation. Think of that. That's really what this is all about. Okay, key issues to address. Time to engage your people. Do you need cross-functional tests? Some questions for you to think about as you start down or go down this journey. Do you need to develop operator skills to reduce variation? So in other words, their base skills of operating the plant. Support to ensure success. Do you need to free up time of maintenance? Do you need a cascading approach to roll out so as not to stretch support resources? And involvement of all shifts in selected areas. Do you have the capability to support the back shifts? Do you have effective frontline leaders on back shifts? If you're going to do TPM and there's multi-shift situation, all shifts have to be trained equally and at the same time so they develop together. Otherwise, you will have challenges. So we've created a little checklist for you. There's 18 items on the checklist, so it's quite extensive. It's been, I think it's going to be emailed to you, and it's also there to be downloaded. So this is summary checklist. So you might find that useful. The idea of it is, what is it that we've found, issue often found? Do we have that issue? Yes or no? If no, what's the next one? If no, what's the next one? If yes, what might happen if we don't address it? How best do we address it? So hopefully that will help you on your journey. So just a quick summary to finish up. Recognize the full potential of TPM cannot be achieved by just focusing on project teams and doing it in an ad hoc way. Develop an effective production area-based team approach with the focus on developing your frontline leaders. Very important, because that's the inductive part of the whole journey. Do the preparation work to ensure you free up time to do TPM properly. Otherwise, you don't. Otherwise, just don't bother. So unless you can free up the time of your operators, unless you can free up the time of your maintenance, there's no point trying to tackle the equipment and doing clean for inspection. Engage your people through emotive questioning. Do you ever get frustrated because the equipment doesn't work perfectly? Great question to ask your people, because what you'll find is just about it, whether it be an operator, maintainer, the planner, the supervisor, they'll all say, whoa, yes, I get frustrated because the equipment doesn't work perfectly. So let's get in a team and let's work on doing something about it. And you engage them quite quickly that way. Recognize to fully implement TPM at a site typically takes at least 5 years to ensure you have, ensure you have a master plan before you start so that you can regularly monitor progress and respond appropriately when hiccups occur, because hiccups are going to occur over a 5-year period. And often they come from corporate, where they want to change a new line, take out a product. It can be regulation, it can be enterprise agreements, it can be a lot of things that can come along. People leave, etc. So we need to monitor it, and we tend to suggest you monitor your master plan on a 3 or 4 monthly basis. So we've got a great range of support here at CTPM. The checklist is just one of a myriad of material that's available to all our members. And finally, Smart and Skilled funding, it's out there for people in New South Wales. Quite significant funding to help you on your improvement journey. We've just been advised that funding's been approved now for another 12 months after the 1st of July. So we've got this year, we're still getting funding at the moment for clients, and we can do it again for 12 months thereafter. So if you're in New South Wales, you can link your TPM to nationally recognised training and get funding, and your employees get recognition. With that, I think I've probably gone a tad over time. I apologise for that, but it is a big topic. After 30 years, I tried to cover it best I could. TPM has evolved. We've learned a lot over 30 years. I think we've all had a go at it. A lot of companies have probably had a go at it and haven't been all that successful, got frustrated with it. But it has, if you don't do it, you're going to be left behind, because you're not going to achieve operational excellence if your equipment does not work perfectly. And TPM is about the only way to achieve that in a very cost-effective way. So with that in mind, any questions, happy to answer now, or you can always email or call me, and I'm more than happy to share with you what our learnings have been.
Okay, thank you very much, Ross. That was a great presentation. So as Ross said, if you have any questions, please press the raise your hand button or type in your question in the control panel box provided, and Ross will be happy to answer that. We did get a comment here, Ross, from Rowan, saying that he thought it was a great webinar and that he's enjoyed the same 30-year plus journey that you have. So it was a great comment there. And while we wait for any questions, I just want to remind you that a recording of this webinar will be uploaded onto our YouTube channel this afternoon, so please feel free to share it with your colleagues. The link to the recording, as well as the link to download the checklist for Australasian TPM, will be provided in a follow-up email to you later today. Due to the time, it doesn't seem like we have any further questions, so we might just wrap it up here. As Ross said, if you have any further questions on today's session, feel free to contact us at any time. And on behalf of everyone at CTPM, thank you for attending, and we hope you enjoy the rest of your day. Thank you.